some knowledge of static electricity, those annoying, unexpected shocks we experience when we're getting out of a car or when we touch a door handle after walking across a carpet. For most of us, static electricity is just a nuisance. But during some workplace activities, static electricity is a critical safety issue that must be addressed. Static electricity is the electrical charge that forms when there is an excess of positive or negative charges on an object's surface. All objects are made up of atoms. The center of the atom, the nucleus, is made up of tiny particles known as protons and neutrons. Smaller particles, known as electrons, orbit the nucleus. Protons are positively charged. Electrons are negatively charged, and neutrons are neutral, that is, they have no electrical charge. Normally, an atom has an equal number of protons and electrons. In this balanced state, the atom is neutral and has no electrical charge. When two objects come in contact, electrons can move from one object to the other, causing their atoms to become electrically imbalanced and therefore electrically charged. This electrical charge is what is known as static electricity. Statically charged objects always try to restore their electrical balance so they can become neutral again. If static charges aren't discharged, they can build up on an object until they have enough energy to jump, in the form of a spark, to a grounded or less highly charged object nearby. This restores the electrical balance of the atoms, and the object becomes neutral again. The spark that can often result from the build-up of static electricity can be a serious threat to safety. Static electricity can be generated whenever objects, substances or people move. So it's not surprising that static electricity is a common byproduct of many workplace activities and processes, including the use of conveyor belts, rollers and pulleys, the movement of substances through pipes and chutes, processes involving spraying, coating, blending or mixing, the wearing of synthetic or wool clothing, and walking on non-conductive flooring surfaces, most commonly nylon carpets. The movement of liquids is another common source of static electricity in the workplace. Whether they are flowing through pipes, being mixed, pumped, filtered, agitated or poured from one container to another, all liquids in motion have the potential to produce static electricity. There are a number of potential hazards associated with static electricity in the workplace, including sudden unexpected shocks that can lead to involuntary muscle contractions and reflex actions, handling problems resulting from unwanted adhesion or repulsion of materials, false readings in electronic devices, and damage to electronic circuitry. But by far the most serious hazard associated with static electricity is the potential for it to be a source of ignition for fires and explosions. In the vicinity of flammable vapors, gases, powders or dusts, a single static spark can have devastating consequences. For static electricity to cause a fire or an explosion, 4 conditions need to be present at the same time. First, static charges must build up. Second, these charges must possess what is called a minimum ignition energy, or MIE. That is, they must be able to cause a spark. The spark itself must then have enough energy to ignite the flammable substance in its vicinity. And finally, the environment must be flammable. Flammable vapors, gases, dusts or powders must be present in a flammable fuel-to-air ratio. As we already know, the build-up of static charges can lead to a number of hazards. So it follows that the aim of most control measures is to prevent the build-up of static charges, or alternatively, to provide a safe way for them to be dissipated before they can result in a spark. Control measures for static electricity can be categorized into two groups. Ones that could be grouped under the heading of workplace engineering controls, and ones that should be included as part of safe work procedures. Many workplaces use specialized equipment to aid in the control of static charges. These include various types of electrostatic neutralizers, including high voltage and induction neutralizers, static collectors, and humidification equipment. However, these engineering controls should not be relied on to control static electricity, especially in flammable environments. These control measures work best when they are used in conjunction with other suitable control measures which are incorporated into safe work procedures. As most of the serious accidents and injuries that are caused by static electricity result from sparks igniting flammable vapors, it is particularly important to consider the use of flammable liquids. Flammable solvents, some with low flash points, and fuels are common in many workplaces. As we already know, the movement of liquids can produce significant amounts of static electricity. Everyone also knows that electricity travels well through objects that we call conductors, and does not travel well, if at all, through insulators. This simple fact provides us with the main principle of how we control static problems in the workplace, and in particular how we deal with flammable liquids. What we're trying to avoid is the build-up of static charges. Static electricity is, in simple terms, high voltage electricity waiting for an opportunity to discharge. If this static electricity is contained, for example with a flammable liquid inside a non-conductive plastic container, it has no easy means of dissipating. If the same flammable liquid is inside a metal or conductive container, and that container is on the ground, the static can pass easily through the metal container and dissipate into the ground. This simple principle of creating a path for electricity to flow through conductors is how static electricity can be effectively managed, and is the principle behind what is commonly referred to as bonding and grounding. Bonding involves the creation of an electrical connection between two or more conductive objects using a conducting wire or strip. Objects that have been bonded all share the same electrical charge, which means there is no electrical imbalance between them, so sparks cannot occur between bonded objects. Bonding, however, does not eliminate the static charge. As well as being used to connect containers, bonding can also be used to connect sections of plant and equipment, so that static charges in those sections can be equalized. Like bonding, grounding also involves the electrical connection of objects. But in the case of grounding, the connection runs from an object to the ground. Unlike bonding, grounding drains the static charges away as they're produced, eliminating the chance of sparking. Grounding works because it obeys the basic rule of electricity that states that electricity will always try to travel to the ground. If static electricity is given the chance to travel through conductors that are in contact with the ground, it will dissipate. In many situations, both bonding and grounding must be used together. For example, when dispensing a highly flammable liquid from a main drum to a receiving container. It is important that bonding and grounding connections are always made with appropriate materials, and they are attached by soldering, welding, or suitable screws, clamps, or clips. In some environments, it may also be necessary to bond or ground personnel. This can be done using special anti-static wrist straps or flexible leads. There are many different situations when bonding and grounding procedures should be used. It is important to strictly adhere to any bonding or grounding steps that are included in established safe work procedures. Included in many safe work procedures, you'll also find steps based on the following general guidelines for dealing with static hazards. When pouring flammable liquids, always pour them slowly. The faster a substance flows, the greater the chance that static charges will build up. Consideration should also be given to the use of anti-static additives. These will act to increase a liquid's conductivity, lower its resistance, and enable charges to pass more easily through the container. Liquids, gases, dusts or powders that are being transferred, discharged, decanted or processed all have the potential to generate static charges. Again, consideration should be given to the speed or velocity of these activities. Nozzles that are used should be made of conductive materials and in some cases may need to be bonded or grounded. Generally, objects nearby or directly involved with processes that include the movement of liquids, gases, dusts or powders should be made from conductive materials and be grounded. In areas where static is a potential hazard, both work surfaces and floor surfaces should be made from conductive materials such as metal, conductive plastic, conductive rubber, untreated wood and unpainted concrete. Surfaces should be kept clean and free of oils, resins, waxes,